Okay, so let's talk about the football problem. A couple of things. You have it in front of you, or you have it somewhere. So we talked about the idea that you have meters and you have feet. And so the football problem says that a football is kicked from the ground up into the air with an initial velocity of 25 meters per second. So that automatically connects us to using this standard form, right? So I'm going to go in and I'm going to put this information into this standard form. What does that mean? It means that I still don't know my time and my height, but I know that I'm going to use my -5 because I'm dealing with meters. I'm going to put 25 into my r because that's my initial velocity. And my initial height, well, if they're kicking it from the ground, my initial height is going to be 0. So the question says, after we think about this model, how high is the football after 2 seconds? What do we do? Well, if we know that t, so this is ai, if we know that t is 2, right, we plug this in. So h of 2 equals -5 times 2 squared plus 25 times 2, and I don't have to write plus 0 because I know 0 doesn't do anything when we're adding. So when all is said and done, I get 30. So h of 2 is 30. So what does this mean? It means at 2 seconds, the ball is 30 feet off the ground. Okay, so if I have my time and my height, that means somewhere in 2 seconds, the ball is going to be 30 feet off the ground. So now it's asking, well, how high will the ball be after 3 seconds? So again, we go through the same process. If the time is 3 seconds, h of 3 equals -5 times 3 squared plus 25 times 3. And what do you know? That comes out to be also 30. So what does that mean? It means at 3 seconds, the ball is 30 feet off the ground. So how does that happen? If the ball is 30 feet off the ground after 2 seconds, how is the ball also 30 feet off the ground after 3 seconds? So I want you to think about that. Well, we know that the ball is going to come up, reach a maximum point, and come back down. So here's it's going to go up, reach a maximum point, and it's going to come back down. Right? So what does that mean? That means, well, on the way up, it's going to reach 30. And on the way down, it's also going to be at 30. So these guys are drawn 2 seconds here and 3 seconds here. So what is the height at 2 seconds and 3 seconds? I can draw that dotted line, and I'm going to mark that at 30 feet. Okay? So on the way up, it's going to reach 30. It's going to go beyond 30 to some point that we don't know yet, and then it's going to come back down, and then it's eventually going to hit the ground. So B asks us, when is it going to be 20 meters above the ground? So if it's 30 meters above the ground at 2 seconds, somewhere between 0 seconds and 1 second, it's going to be 20 meters. So how do we do that? I'm going to bring that up. I'm going to keep our model right here, because now the question is when is it 20 meters? So that means we have the actual height. So I plug 20 into the height. I have -5t squared plus 25t. Okay? And so how am I going to solve this problem? Well, I have a quadratic, so I set it equal to 0. I'm going to divide everything through by -5 because I can. And I'm going to do -5 so I can get my a to be a positive one, or a positive. So 0 equals t squared minus 5t plus 4. How am I going to solve this problem? Am I going to use the formula? Nope, I'm not going to use the formula. What am I going to do? I'm going to factor. I know I can factor this. This is a piece of cake. T minus 4, t minus 1, factors of positive 4 that add to make negative 5. That equals 0. I set up my trusty t-chart. T minus 4 equals 0, t minus 1 equals 0, so t equals 4, and t equals 1. Okay, we're going almost off the edge of the paper. So what does that mean? That means I can bring this information back up to my picture. So at 1 second, it's going to be 20 feet, not feet, I'm sorry, meters. And then at what other answer is for my t? At 4 seconds, it's also going to be at 20 meters. So that's my A, B, and C. So there I know, right now, I know at 1 second it's going to be 20 meters, at 2 seconds it's going to be 30 meters, at 3 seconds it's going to be 30 meters, and at 4 seconds it's going to be 20 meters. So how am I going to figure out a couple of things? Now this isn't actually on the problem. How do I figure out how high this got? Okay, so again, there are two ways that I can figure out how high. I can go and look for my vertex. My standard vertex is going to say x equals negative b over 2a. Okay, so I can say, well, y equals negative 5x squared plus 25x. Of course, it's not really y and x, it's h of t and t, but I'm putting it as an x to make it a little easier for you. So we have negative 25 over negative 10, and that's 2.5. And does that make sense that this is my center point? It does. It makes sense because it's going to be going up at 2 seconds, it's going to reach a maximum, going to come back down at 3, so clearly right in the middle of 2 seconds and 3 seconds is 2.5 seconds. Okay, so you could have done that without any math at all. You could have just looked at your picture and said, oh, well, where's the middle? I have the middle. It's directly in between because we have our line of symmetry. So now that I have 2.5 seconds, I have to put it in my function. H of 2.5 equals negative 5 times 2.5 squared plus 25 times 2.5. Okay? And I'm going to do my math. I haven't done my math yet. So negative 5 parentheses 2.5 parentheses squared plus 25 times 2.5 using my parentheses, and I get 31. So h of 2.5 seconds is 31.25 meters. So that means at 2.5 seconds the ball is at a maximum of 31.25 meters. So I can write a sentence there. At 2.5 seconds, the ball reaches the maximum height at 31.25 meters. And there's our maximum height. So the final question in this says, when did the ball hit the ground? When did it come back down to the ground? Okay? I don't even want you to think about doing any math for this. We can just look at our picture. If the ball reaches its maximum at 2.5 seconds, when is it going to hit the ground? And the answer to that is 5 seconds, because it's twice that. So that's how long the ball is going to take after it's kicked to hit the ground. So I'm going to just make a simplified version of that picture according to what it looks like on the worksheet. Okay, so the guy is kicking the ball here. All right, it comes up. Okay, at 1 second, it's at 20 meters. end at 4 seconds. It's also at 20 meters. And the ending is at 5 seconds. So there's another way you can do that, right? If it's going to be 1 second from 20 here, it's also going to be an extra added second from 4. So 0 to 1 second, 0 to 20 meters. 20 meters to 0 feet, 4 seconds to 5 feet. And so there's your picture. So that's your when. It's at 4 seconds. And here is your when at 5 seconds. We could add what we also found to our drawing if we wanted to, right? This is at 2 seconds if we wanted to. This is at 3 seconds. It's not to scale. And here we have 30 meters. So we have all of these beautiful points on our parabola. And of course, the last thing that we could add if we really wanted to is the maximum height. And again, at 2.5 seconds, the maximum height is 31.25 meters. So 2.5 seconds.